Today we are solving the question rotate by 90 degree. Let us understand the problem first. We are given a square matrix and we need to rotate this matrix 90 degree in clockwise direction without using any extra space. So we are given this matrix and after rotation we get this 90 degree direction in clockwise direction. So first talk about the brute force approach. The brute force approach is very simple. We make a copy of this matrix and then we copy the matrix. This is the main matrix and this is the copy. And we will copy the element like this. So this goes here, this goes here, this goes here. The problem in this approach is it is using extra space, which is order of n square. The n is the number of rows of the matrix. So time complexity is order of n square because this is traversing the array. So we are said to solve it in order of one space, that is no extra space used. So for solving this, first rotate this 90 degree in clockwise direction. Now carefully observe the two matrix. If you see the first row, the first column becomes the first row. The second column becomes the second row. The third column is become the third row. So the orders are the opposite. This is 147, this is 741. So in which matrix operation we get the rows are the columns and columns are the rows. This is matrix transpose operation. So we are going to do the matrix transpose operation on this matrix. So after doing transpose, 7 goes here, 3 goes here, 6 goes here, 2 comes here, 4 goes here. This is the matrix after transpose operation. This is the original matrix. Our transpose means we are swapping these two elements. These elements with this with this with this. So that's what we done. Now if you look carefully with the output and after transposing the matrix, the order of the rows are the reverse in the order in output. So we need to reverse every single row in the matrix. After reversing, we will get the result. So let's reverse. This will go. This will go here, and this will go here. So this is the output. This is the exact output. So we not used any extra space here. So the space complexity remains order of 1. And let us talk about time complexity. What we have done here. We have transposed this matrix. First operation is transpose of the matrix. For transposing the matrix, we are swapping this number of elements with this. So the complexity, this is how number of elements. Here is, for if this is number of rows, then we have 1 to n minus 1. So we done the n into n minus 1 by 2. So this is so time complexity is order of n square. For first n square, then we done reversal. We reverse each row. Number of rows is n, and for reversal we need n by 2 times. So this is the complexity, which is order of n square time complexity. So let us look the code. Yes, we written a swap function rotate. This is the here. First we transpose this matrix. For transposal, I said that we will traverse from only this part of the matrix. So for traverse, this is zeroth row, it is one, this is two. So we start traversal from 1th row and 0th column. So here I write I equals to 1. This is 0th, 1th row and 0th column. I goes to j goes to less than I, because we are going up to this, and here I is equals to j, and this part is I is less than j. J is less than I. So we wrote j is less than I. J is denoting the columns. So we swapped I of matrix of ij with matrix of ji. This is ij and this is ji. So ij and ji will be these elements. So we rotate, we swap these elements. So we done transpose of the matrix, and after doing transpose, we need to rotate each row of that matrix. So we traverse through all the rows. This is I equals to 0 to I less than matrix dot size, and for reversing each row we write this matrix of I and matrix of ij with matrix of ik. I here I is means that we are made the rows constant, because we are doing like this. We are swapping with this. this, this. So we are swapping with the same row. So this is, and I is from J is J and K is pointing to the row. J is the first index where initially in first index, and K is initially last index of a row. So when we will stop when J becomes equals to K, and J we are increasing J and decreasing K, and here we swapping the elements, and we need not to return anything because this is void function, and we are send, and they send us a reference of the vector. This is called Alice.